Welcome to AWS Review, a weekly look at what's happening with AWS and how it may change how you do business. I'm your host, Michael Krause. I am a CTO, technology evangelist, and all-around geek.
And I'm your co-host, John Affolter. I'm a technical architect. I specialize in AI, and I'm also a ChatGPT enthusiast.
I love it. I love it. So today's episode, we are going to be taking a look at Amazon EventBridge and seeing what it is and what it can do for you in the various types of challenges you might be encountering.
Yeah, Michael, I know we've talked about EventBridge for a long time and been watching over the evolution here. And I guess, let's just kick it off like we usually do. And what is EventBridge and how does it relate in the ecosystem of AWS?
Okay, so very simply, EventBridge is a service from AWS that provides an event bus, or the ability to create event buses that can be used to publish and subscribe to events. Okay, so I guess that all depends on people understanding the definition of event bus and events in this type of a world. And event buses aren't necessarily new. They've been around for a while. Probably one of the better known kind of event bus systems out there is TIBCO. And people have spent a lot of money building out systems based on TIBCO. But the general concept for people who may not be familiar with it is that an event bus is basically just a way of announcing something to people who may be interested. And events are typically fairly concise announcements, if you will, right? So the announcement could be as simple as, hey, a new file arrived. Or we just finished processing this deposit transaction for you, right? And then other systems who might be listening to that event bus can subscribe to events that match a certain criteria, right? So you might have a system that randomly, samples deposits to do fraud checks on them, right? So it may be listening to the event bus for any notifications to whether or not a deposit happened, right? It doesn't care about withdrawals. It just cares about deposits. And you could have 30 other systems also listening for deposits or other things. So it's a way of asynchronously communicating information about things that have occurred, changes that have happened inside a system so that other systems can react to them. That makes sense?
Okay. Yeah, no, absolutely. So, talk about, the different, you kind of mentioned they're usually small, little, incremental updates. Talk about how that fits in to the big data world and how, maybe you have a lot of systems and there's a lot of different throughput and there's a lot of different things coming in.
Right.
And how does that parse out and where does it fit into that architecture where you might have batches, you might have streaming, et cetera?
Right. So there's a little differentiation I want to do here, especially if you're using AWS. There's a lot of different things out there. Kinesis is one of those things. You also hear about Kafka and similar streaming technologies. And the question always comes up, EventBridge, that's like Kafka, or that's like Kinesis, right? Not really. Kafka and Kinesis are really built around streaming data, right? So they've got certain contracts that they have to adhere to, like maintaining order. Right. So if I'm streaming real-time data, something that happened 2 seconds ago should arrive to you before something that happened 1 second ago.
Yep.
So tools like Kinesis enforce that. Event buses typically don't have a need to enforce that. All they need to do is notify people that something has occurred. Right. So you can combine these things together. So you might throw data onto Kinesis to be consumed downstream, but you also might raise an event and let other systems know that this data has arrived.
Yep.
Or you might have systems who are interested when certain types of things happen. So you might be running data through Kinesis data streams, right?
Yep.
And you could be using Kinesis analytics to basically be observing that data stream for certain patterns.
Yep.
And if those patterns occur, you could raise an event. So an example there would be, say you're bringing in IoT data, right? And you're watching for IoT data that indicates a failure where something has to be fixed or repaired.
Yep.
Okay. You could be watching that data with something like, Kinesis Analytics or other tools. And if we observe something that indicates an error has occurred, we can raise an event that then another system that is in charge of creating tickets and rolling trucks and sending out for repair can be watching for those types of events and react to them and actually perform that operation.
Yeah, so you can there's a way to kind of parse out through the massive amount of data that's coming in, and you can kind of modularize and be able to send that to the subject matter experts that are best at dealing with that specific task. And
the event bus is typically not a great tool for processing data and moving data. I always refer to it as notification. And I've seen implementations where it's part of a moving data, right? So I've seen some systems where you might have one system that's responsible for integrating with some other system, right? And it gathers in the data, and the data, might be a meg or two in size. But whenever it receives that data, it might, in this case, store it on S3, but raise an event that says, hey, we've received this new data set.
Yep.
And in that event, we may say, and here's where you can find it.
Yep.
So they're not responsible. They're not using the bus for moving the data around or shipping it. Again, they're still using it for notifications.
Yeah. So this, EventBridge really, and we talked about EventBridge a while back, but really it looks like it's kind of evolving more into almost a central nervous system that kind of distributes to more purpose-built systems as data flows through the system.
Yeah, it does. And I think it's important to take a look also at the other systems, the other services that AWS provides that do kind of similar types of things.
Yeah.
Right? We talked about Kinesis, which does a similar type of thing, but it's time series data, and it's really meant to process streaming data. Right? That's what it's built for. Could I throw events on Kinesis? Absolutely. But what's the downside is Kinesis really doesn't have this concept of subscribing to things that match a pattern. Right? With Kinesis, you can have multiple consumers, but they all consume everything that comes through it.
Yeah.
And then they have to decide after they've consumed it whether or not they're interested in it.
Yes.
Right?
Yeah. So you have you could have a cascading amount of information that you're consuming the wrong people are getting it, thus driving up all the prices that you're getting.
Right.
So
whereas with EventBridge, what you do is you say, oh, we have a bus, and you create what's called an EventBridge rule that defines a pattern. And you say, if an event matches this pattern, then send that to me. And later on, we'll talk about how you can send it to it. But that's basically EventBridge takes on the responsibility of the pattern matching. Right? Whereas you could do the same kind of thing with Kinesis, but you have to get the information off Kinesis first and then apply your logic in your own code.
Yep.
To make that determination. Now, somebody might say, oh, that's no big deal. That's very doable. Okay. But how about if you've got, a billion events per second coming in and you're only interested in 5? Right? Yeah. Okay. So, you could process that billion events per second to find that needle in the haystack and then process it. Or you could just let EventBridge do that using the pattern, using the rule, and only let you know when those 5 have come up.
Yeah, and obviously that makes you be able to really make things a lot more purpose-built and be able to kind of sift through that massive amount of data again. And I know that there's other services like you mentioned that kind of do some of the same stuff. I think, I would say kind of a beginning stage of event bus would be the SQS plus SNS type
Right.
architecture.
Right. So before EventBridge really grew into what it is today, that's typically what you saw. You had SNS, simple notification service. That when it first came out, did things like it allowed you to invoke an HTTP endpoint with a message, send an email, send an SMS, a text message to someone, and then it became more of a general notification system that you could then have applications subscribe and pick up those notifications. So very much like EventBridge from that standpoint, you could put a notification out there, an app would pick it up. And they also supported some pretty basic filtering. So you could actually say, I want to listen for messages that match a certain pattern, right?
How does EventBridge come in and, where do you feel like because we talked about this a lot, where do you feel like that big lift was that really made it to where a company would want to learn a new, kind of a new paradigm in a way, I guess, but or
an old paradigm, yet a new paradigm for stuff.
Yeah, an
right?
old paradigm, but just a lot of new ways to connect everything, and just to extend maybe other things that would be working independently previously. I guess.
Yeah, it's been a growth because when EventBridge came back, and we need to come back out and talk about SNS, SQS a little bit more in a minute.
Yeah.
But when EventBridge first came out, it was really kind of geared up for allowing external organizations and SaaS software to send stuff into AWS for you to pick up.
Yep.
And that still exists, but and I don't know the inner workings of how they came around to this, but eventually AWS said, EventBridge really should just be an event bus system. And they started adding capability and features. You no longer had one single event bus that was just kind of used. You could create custom buses for your own use, so you could have different event buses for different reasons. And they added other things like schema management for event schemas and structure. And that's literally in the last probably 2 years, it's really kind of evolved up. It kind of was working its way in that direction, and it kind of suddenly crossed the hump, if you will, and became something that's very, very viable. And like you mentioned, prior to that, if you wanted to solve this, you used SNS, because SNS is kind of a one-to-many type solution. You put a notification on SNS, and everybody who's interested gets notified, right? But the problem is what do you do with that notification? Right.
Yeah.
So to allow it so it's not a constant synchronous kind of thing, people would actually then take the output of SNS and attach it to SQS. So you've got a queue, which is really kind of a many to ones type scenario. Many things can write to the queue, but really only one thing can process a single item on a queue. They're designed to work that way. You can have multiple things process multiple items at the same time, but it's typically kind of one consumer type model. And what this allowed them to do is SNS became kind of the announcement hub. SQS became the kind of the buffer, asynchronous buffer that all those went into, so then the app could in its own time process those, right? So if you're familiar with advanced queuing protocol, AMQP, Advanced Message Queuing Protocol, and the concept of topic queues that are attached to then proper message queues. That's kind of that same thing. And what EventBridge does is it brings you that same capability plus a whole lot more, which we'll talk about, in a single package that's kind of purpose-built for this, right? And one of the big differences in my mind between EventBridge and SNS, because you can do a lot of the same things that way, one of the big differences is the filtering. So the rules that you can write to filter the events in SNS are pretty basic, right? You can look at just basically metadata attributes around what's the notification. With EventBridge, not only can you do information at a metadata level around the message or event, you can also do it in the content. So you can actually look in the content of the event being sent. and see if the content matches a particular pattern. Right?
So really, it's not just the basic pieces of data that's flowing through a system that maybe a log could pick up.
Right.
It's also all of the information connected in there, and then it's processing that rules based engine on a lot bigger amount of data, essentially, too.
Right. So a simple example, going back to, hey, we did an integration, we got this file, right? Mm-hmm. You might raise an event that says file received. Or transaction file received, right? But you've got 5 different companies that you get transaction files from.
Yep.
Right. So the event might be.
They all want to know. They all want to know if you got it, and then they want to know, and maybe each. So how about this too? Is especially with the new object storage, and not to get off topic, but maybe there's different. It does the same event can come in, and then maybe for each of those 5 places, maybe they get sent different pieces of information depending on the event. Is that possible? I mean, just because there could be different, there could be different ones that have different.
So yes and no, right? So when the event comes in, or when an event is raised and put on the bus, it is the event.
Yeah.
Right. And you can filter, you can build rules, you can say, hey, I'm interested in the file received event, but only if inside the data on that event it said it was received from company XYZ. Right. Yep. So I can do all of that. But every subscriber, every person who says I want to receive this event gets the same event.
Yeah.
Right.
Okay.
So if I want to say I want John to get this event, but I want to reformat it before John gets it, I need to have a Lambda or a piece of code that subscribes to the event, processes it, maybe trims out certain things and sends it to you. Yep. Now, let me turn that around. If you're part of the organization, you're just another microservice, right?
Yep.
And you're interested in that event, but you want it not in the native event format, but in a slightly different format. Mm-hmm. The other thing you can do is when you create the rule, you can actually create some transform information to transform the event into a slightly different structure. Okay, but that's on the subscriber side who's just defining that.
Okay, that makes sense.
So it's not an information control thing; it's more of an information mapping thing to make it easier to consume.
Yep, yeah, that makes sense. And so there's obviously a lot of things that you could group together in one single event. What are some of the sources that you can pull information from and be able to put together and distribute in these other services? I guess there's a lot of integrations here. It looks like.
Yeah, you mean like how can I pass messages to different services?
Yeah.
So this is the other nice thing that EventBridge has over SNS is so if you think about, I have a bus, I have events that go onto the bus, and then I have these subscriptions or listeners who are kind of watching the events going past and picking out the ones that apply based on a pattern, right? Mm-hmm. But when they pick them out, what do they do with them? So what happens is every single rule on the EventBridge, it has a method of what to do or just basically transmitting that event, right? So a common one would be SQS, right? Mm-hmm. I still don't want to do synchronous communication with this application over here, but whenever an event that matches my pattern shows up, I want to toss it on this SQS queue so that app can process it in its own time, right?
Yeah.
The other thing it can do is it supports API calls. So you can invoke a REST API. You can say, hey, when this event comes up, call this REST API with that event data. Mm-hmm, mm-hmm. Right? So now I can do synchronous stuff. I can do all kinds of different things. I can trigger ECS tasks. I can fire off glue jobs. I can fire off SageMaker pipelines. There's all kinds of endpoints that EventBridge supports. It says, hey, when an event of this type comes up, do this. Yep. It's a very rich ecosystem they've been building, and that doesn't even include just the ability to say, fire this Lambda and in Python or whatever, I'll just go write the code I want to have do what it does, right?
And I think that's that's pretty powerful, especially as we get into this. As much as I say I'm a ChatGPT enthusiast, obviously there's some danger in that, right? And
Yep.
especially. But there's also a lot of really cool stuff with it because you can continuously ask it to reform and rethink and what about this and what about that, and that's, I think, with EventBridge, I think that you could get to some really interesting things that it could kick off, I think, and
and this is kind of a paradigm shift in how people think, right? And there are quite a few people out there who already think this way and are good at it. More and more companies are needing to, which is to move away from imperative thinking to responsive thinking, right? So rather than saying, a person wants to place an order, right? So I have to go through and I have to call my inventory verification, wait for them to get back to me and say, yes, I have that. I have to then call the credit card endpoint and wait for them to come back and tell me that the credit card's good, and all these things. That's an imperative structure. It has to, it's command based. I do this and then I do this and then I do this and then I do this, right? Responsive structure is not command based. What it does is it reacts to a change in state.
Yeah.
Right. So now in this scenario, and you have to think about the world a little differently when you do this. Now in this scenario, the person says place order. And what you do is say, all right, your order's placed. We'll get back to you with confirmation. Right?
Yep. So
we'll send you a confirmation in a moment. And all the system does, and it says is, hey, here's an order placed event with basically an attachment to a shopping cart. Okay? And then the inventory system picks that up, and on its own, it goes and verifies inventory and says, hey, inventory's good or inventory's bad. And if inventory's bad, you might have a system that reaches back out to the customer and says, hey, we just noticed that we're short on inventory. It's going to be an extra 2 weeks. Is that okay? Right? At the same time the inventory system is doing that, the payment system has picked up that same event, and it's processing the credit card. And if the credit card fails, it basically flags the order as not paid. And again, the system sends something out to the customer saying, hey, that credit card failed. Go here to go and enter a different credit card for us.
Yep.
Right?
I noticed it on my Amazon accounts when I'm buying up all these O'Reilly books. I have one on there, and it's always lets me go through with the thing. And then about 15 minutes later, it says, hey, you used the wrong card, basically.
We have a problem. We have a problem. But that does a lot of different things. One is it creates isolation of control and of code. Right? So you don't end up with this big spaghetti monster of code that's doing all these different things. You've got nice, clear responsibilities and boundaries around some of these different things.
Yep.
The other thing it does is it allows independent scaling. Right? You don't have to scale a monolith now. Now, if you get a big load, that big load may be a 5% bump on the UI service.
Yep.
But it might be a 20% bump on the inventory service and a 40% bump on the payment service. But they can all scale independently in finer granularity.
Yeah. And I mean, I think that is a huge thing, especially as we get into this API driven world as well.
Yep.
And, how does this shift, you made a point there already with, you have a lot of experience with this. How do you shift from that monolithic architecture and, into this distributed system? And where does EventBridge play well? Where does EventBridge maybe not play so well in these larger distributed systems?
So something like EventBridge, some approach of asynchronous messaging, let me put it that way, right?
Yeah.
Whether it's SQS, SNS, event bus, anything like that, some approach to asynchronous messaging is needed to have a good asynchronous system, right? Where everything kind of works in its own time, scales in its own model, and you don't have a lot of tight coupling, around things, right? I don't have to wait before I can send a response to my user for every one of these things to happen. I can be very responsive to my user because everything's being asynchronous, right?
Yeah, so you can work independent, or everything can work independently. There's not any sort of waiting for other things,
Yes.
essentially.
And something like Event Bus, specifically Amazon EventBridge, is a technology to make that happen, right? And I'll talk at a couple levels here. EventBridge is a great technology. I love it. I think it's an excellent technology for helping coordinate these types of things. But let's take it above, because I could make this happen with SNS and SQS. I could make it. There are other technologies I could apply. So at the concept level, the concept is, how do I build a system that is event driven, right? So actions don't happen because somebody said, do this now. So actions happen because somebody said, this has changed.
Yep.
This state change has occurred. The customer has hit the purchase button. Right?
Yes. Yeah.
That kind of thing. So that is the bigger mindset, right? And if you think about it, a smart person would look at it and say, well, what's interesting here is through a savvy building of events, I can chain work together. Right? Well, what happens, so for example, you can't ship until the payment processes. So let's assume inventory is fine, right? You may say, oh, I'm going to have an event that says, customers said purchase.
Yep.
And I'm going to have another event that says purchase payment approved. Right? And the payment system may respond to the customer said purchase event, and the order shipment process may respond to the payment approved event.
So then those systems can then work independently as well.
So now, in a way, you're able to orchestrate work across multiple systems by using those events. Right? So you can do that in a lot of different ways. I've seen systems and worked on systems that were monoliths that actually used eventing internal in the monolith to do the same thing, right?
Yep.
Rather than being, specifically directive or imperative about it and procedural, we'd actually say, okay, we're gonna basically express events and let different parts of the code, which are running as actors in different threads, respond and act upon those things independently and asynchronously, and minimize the amount of actual synchronous code that's required to process user requests.
Yeah, so you can, you kind of almost define what a certain type of event looks like, and then it's, and like to your point, then it's responsive. It's not trying to figure things out as it's going through the process.
Right.
So.
Now, the other piece of doing this is that it creates a lot looser coupling in your systems, right? So, for example, the payment system doesn't care that the order was placed with the online system. Okay. The payment system is just basically processing this order request event, or the customer purchase event. That could happen at a kiosk. It could happen by somebody at a point of sale system. It could happen, you could have a bunch of different systems. You could have different apps in different countries doing it. You could have microsites that are white labeled for different people, all emitting the same event. You could have a single payment processing engine running in the background that's just driven by events. It doesn't care. Okay.
It's just all it is doing is just routing based on what people want to see at certain times.
Exactly. And the other side of it is the front end systems don't care who is doing the payment processing.
Yeah.
Right? Now, so, if you tightly couple those even as separate services, your front end system has to know the REST endpoint or the other API to call to do the payment processing. You change that. If I've got 20 front end systems, All 20 front-end systems have to change to use the new one.
Yep.
Same thing the other way. If this thing is expecting calls from these different systems and they change how they're going to do things, there may be some more stuff that has to be done there. But in the event system, all you're doing is just raising a flag saying, hey,
this has changed over here.
This happened. And anybody
Yeah.
who's interested in that happening or needs to respond and react to that can pick it up and go. It might be one. It could be 100 different systems, right?
Yeah. Wow. That's, it seems like there's just a plethora of different use cases that you're going to be able to use with this. And
yeah, I think the challenge. Oh, I'm sorry.
Yeah, go ahead.
I was going to say, I think one of the challenges, while it's really good, it requires that people think a little differently when they're designing. Mm-hmm. It also requires that they think a little differently when troubleshooting, because I can't just simply follow, procedure calls in code, right? I can't open up, IntelliJ and hit, was it Control B, or Eclipse and hit Control B and bounce to the definition of that particular call and then keep drilling down that way, because these are network calls. And not only are they network calls, they're not specific. I can't say, I called the XYZ API. I have to go over to that code and look at it.
Yeah.
What you need to do is say, well, I know I raised this event. I need to go know who goes and responds to that event to figure out why that didn't happen.
Yeah.
So understanding and documenting that architecture is very important.
Mm-hmm. And when you're creating these systems, how do you make it to where you're defining these events the right way, and you're making sure to that you're creating a system to where even let's say you're using machine learning, what are you doing to find and then define events, define anomalies, things like that?
Yeah. So one of the kind of things that becomes really important, especially as you start using something like this more and more, is consistency and standards. Mm-hmm. Right. And, with EventBridge, AWS provides kind of a standard, what I'll call wrapper around the event, that expresses certain things like, what is the type of event this is, right? What was the source of the event? Or in other words, who emitted or raised the event? What is what's the content of the event, right? When did the event happen? A timestamp. So there's a kind of a wrapper. And if you think of it as like a JSON structure, right? So there's a piece of JSON, and then nested in that is this, event. They call it event detail, right? There's event, which is the name of the event. And then there's event detail, which is the actual content of the event, right? Oh, here's a pointer to the S3 bucket where the data is, and here's who the data came from, and, those types of things. But what happens in that event detail, that structure, needs to be defined. Because if you don't define it, then it's hard for all the different people who might receive that event to figure out, how do I parse this? How do I pick it apart? So that's, just a general rule. You need to do that. What Amazon does with EventBridge is they've brought forth a schema registry. So you can take these events, define them using JSON schema and what is it, the Open API protocol. You can choose one or the other. They've got more support for some things with JSON schema than the other, so I tend to lean towards JSON schema when I do definitions. But you can define the schema of your different events and load them up into schema registry, and that gives you a few different things. The first thing it gives you is you can go into the AWS console, go to schema registry, and you can search. And you can find all the events and the description of them and the structure of them. So you can say, hey, do we have an event for the X, right? Do we have an event for this happens? You can literally go and search the events and see them. The other thing it has is code bindings. So for every single event, it'll provide bindings in like JavaScript, Java, Python that will automatically unmarshal any event and provide you an object representation of it. And the same thing for sending. It'll provide you an object representation that you can populate, and then it'll provides the code to marshal that so that it's consistently put on the in the same format on the event bus. So that makes things pretty simple. And the AWS toolkit, I don't use Eclipse as much anymore, so I can't speak for it. But for like IntelliJ, if you're users of IntelliJ, if you download the plugin for the AWS toolkit, right from there you can go find your event in the schema registry, and right from there download and pull those code bindings right into your code.
Yeah, I mean, there's a lot of interesting plugins. I think I'm using VS Code right now,
yep.
but I think I almost overloaded all the plugins that I had here, and I don't know if it's working very well. But I see the AWS Toolkit as the same for Visual Studio Code as well.
Yeah, it's just I don't use VS Code, so I can't speak to it specifically. But I would assume that the toolkit for Eclipse, the toolkit for VS Code, the toolkit for JetBrains is all basically has all the same features.
Yep. Okay.
I would be surprised if it didn't.
Yeah. No. You never know these cloud wars out here. You never know what's going on.
Yep. You never know. You never know.
But yeah, I mean, I think with I think EventBridge though helps you kind of put a lot of things in perspective just about your workflows as well.
Yep.
Where do you see kind of the next possible evolution of EventBridge and maybe that is an event in itself, I guess,
Yeah, I think if I think about where EventBridge is going, I think higher performance, more increase again. Behind the scenes, it's little things, right? It's the quotas are increasing and, things like that, so that people can use it more and more, better management of the schemas, visualization of the traceability of who's using events, right? So EventBridge knows who's subscribing to what events, right? So to be able to go through from a debugging and troubleshooting perspective and say, okay, system A is emitting these 5 events, and here are the systems that are actually ingesting those different events. It actually has enough information to be able to say, here are the sources and destinations. Let's give you a visual graphic of that, similar to how it gives you visuals for step functions and things like that. So I think there's a lot of enhancements that can be done, but I think the core is there.
Sounds like a graph.
Yeah, graph database opportunity. No, I think the core is there though, and it's matured to a point now where it's extremely viable to use, and more companies should be using it.
Yeah, I think I think that it's I've like I said, I remember seeing all the blogs start to come out, and I was like, my spidey sense went off with it. I'm like, I think EventBridge is coming up here. It's
absolutely.
It's been fun to watch the evolution, and I'm really interested to kind of see a lot of just the playbooks that it can come up with too, and that's it's a cool thing seeing the community, build out some of these as well.
If you want some kind of higher level perspective, and I recognize there's a bit of marketing spin in this, but at the 2022 last year, at the 2022 reInvent, Werner Vogels in his keynote speech talked a lot about async. And he didn't talk specifically about EventBridge, but he talked about asynchronicity as the world continues to grow and data scales and things like that. And it was a really interesting talk and a lot of really interesting examples that kind of demonstrate the value and importance of being able to separate these responsibilities and allow them to act independently through a kind of loose coupled communication mechanism.
Yeah, I think that makes sense, and I know he also talked a lot about quantum, right? The ultimate async, the synchronous async, right? So I'm interested to see kind of how that evolves. And hey, there's another one that I brought up earlier, and like, well, let's wait on this one a few years, and I think it's going to be a similar thing. So,
Exactly.
um,
Exactly.
I guess what else have we missed here?
Yeah,
I think,
we've
just
talked
the
about a
time
lot of
series. I
stuff.
think we looked at it. We looked at,
Yep.
how we can look at the time series.
I I
Um,
think the only thing maybe that we haven't really talked about or mentioned is cost.
yeah, I was looking right at
And
it.
again, we're not here trying to provide the deep dive today on how to implement
Oh man,
EventBridge, but
that's a whole
but
nother. It could have its own payment system
yeah,
dedicated just for that.
yeah,
So
exactly. But as always, go to the AWS website, take a look there, look at the pricing there. You'll get all the details. But kind of the general one that you need to know is that AWS charges about $1 per million events published. So
a
for
buck a
so if
million.
yeah, so if you're doing a million events, per hour, it's going to cost you $24 a day.
Yeah, hey, it's one for every hour.
Yep.
That's dollar a day keeps the system crashes away, I guess.
Absolutely, absolutely. Yeah. So I think that's probably kind of, yeah, I won't say in a nutshell because we talked for a while, but
Yeah.
that's pretty much the overview of EventBridge with a little bit of spice in there.
Yeah, yeah, it's in a cosmic egg, maybe bigger than a
Exactly.
nutshell.
Exactly.
Awesome.
Exactly. All right.
All right.
Well, I think we should probably wrap it up at that point. And so, for everybody listening, thank you again. Please subscribe. Please follow us on Twitter and LinkedIn. And look forward to the next episode we put out. So, thank you all.
Thanks all.